parents, welcome, and students. So a lot of you have asked me for some videos to explain homework. So the goal of these videos, if you subscribe, is to see how I teach it during class. And then on the descriptor below, you can just fast forward to whatever the skill is and watch that video at home with your children. In case you want to hear yourself, this will hopefully help. So the first week of school, we cover number sense in base 10-1. And the way that's going to look on the descriptor below is NBT 1 for 4th grade. And we cover all the number sense in base 10 skills all through the first 6 weeks of school. And these skills, when you and I were in school, basically were described just as number sense. But now we describe them as number sense in base 10 because the main focus for 4th graders to understand is that our number system is based on bundling with our 10 fingers. And what this looked like in kindergarten was lots and lots of counting real life objects. And we'd count fingers and hands and toes, and it was always bundles of 10, and we'd count on the calendar and we'd bundle at 5 because one hand represents 5 and 2 hands represents 10, so we'd start bundling in 10s. And then you got to 1st grade and 2nd grade, and your teacher started to use computational symbols for the numbers. So the symbols started with just the basics till you got to that magical number 9. And at 9, the focus of 2nd grade was to really get kids to understand that our number system is based on bundling to a 2-digit number at 10. And so what happened when you reached that next one was you no longer had any single objects, you had a bundle of objects. And this represented a whole set of 10 of those. And so this was 10 times less than this, and this was 10 times more. And then, of course, the next digit would be 10 bundles of that, and 10 bundles of that. So that brings you up to about 2nd grade. And then in 3rd grade, they let you play with comparing bundles of objects. So they started really talking to you about 0 and how those zeros represented either 0 single objects, or a bundle of 10 objects, or a bundle of 100 objects. My job in 4th grade is to expand on that knowledge even more. So now I show the children the basic place value frame. And in the basic place value frame, you show that each of these places has a value, and the values are always in whole numbers: 1s, 10s, and 100s, 1s, 10s, and 100s, 1s, 10s, and 100s. And then you introduce them to the word period, and that's a multiple meaning word. In language arts, it means the end of a sentence, but in math, periods represent these different bundles of place value. So this first period is called the ones period, and the second period is called the thousand period. And I'm sure you know the third period is called the millions period. But in our class, we actually don't refer to this period as ones. We tell them it's ones, but then we say, in our class, we're going to call it the no name period, and that's because nobody ever says the name of the ones period. They usually just say, I have 198. And so we say, I have 198, and just cover your mouth. And that way you remember not to say ones. So we practice a lot of reading and writing numbers, and we start by putting in a silly one. Just all the digits into the frame. And then we talk about how each of these has the value of 1s, 10s, and 100s in the bundles, and 1s, 10s, and 100s in the bundles. And so if I read this number, the number says 123, and then I say the name of the period, million. Then there's a comma, and it leads me to the next period, 456,000. Then there's another comma, 780,000. 9. So once they understand how to talk about these numbers, then we really start to talk about the values. So this first skill we cover is number sense in base 10-1, which is, do you really understand that when you're doing this, what you're really doing is grouping these real life objects into 10 times more this direction and 10 times less in this direction. And we usually start off by talking about money, because everybody loves money. So I'll have the students choose a number they might pick up in an envelope on the street. Let's say they pick up $482. So now my question to them, if they really understand that there's 10 times more and 10 times less, if I were to ask, how many $100 bills do you have here? Most of the students know that I have 4 $100 bills. And then we talk about why that is. Well, because 4 with 0 tens and 0 ones is in the hundreds place, so I know I have 4 $100 bills there. And they usually understand that. And then we get a little more challenging and I say, okay, how many $10 bills do you have? And that's where a lot of them get a little stuck, but they need to think about, well, think about it this way. If I had one $10 bill, then it would look like this. But I don't have one $10 bill. I have this many ones, but I'm not going to pay attention to that because ones are smaller. But I have this many, not just one. The ones place is being held by the 2, but the other places, I have 48 $10 bills. And that's kind of fun for kids to think about splitting money up. And then we go to a problem that's a little more challenging. We say, okay, let's say we have 1,000. So then let's say we have 1,234. How many $100 bills do I have? And then the kids usually automatically put the 1 and the zeros holding the ones and the tens place. And then we talk about, I don't just have 1. I'm not going to pay attention to tens because tens are less than a $100 bill. I'm not going to talk about ones because ones are less. This is how many $100 bills I have. A bundle of $100 bills, a bundle of 10 of them, and 2 $100 bills. So you can see how using money and talking about the place value helps them deepen their understanding of our number system. Then you can really get to really challenging ones of 456,291. How many $100 bills do I have in that? And that's not so challenging now because you know that you don't count the ones place, you don't count the tens place. You are going to count how many hundreds. So now you just block those in, rearrange the commas into the place value frame we talked about, and now you can say, in all those millions of dollars, I have 34,562 $100 bills. Okay, so we've covered number sense in base 10-1, and so now we're going to cover number sense in base 10-2. And number sense in base 10-2 covers 3 skills. First, it talks about how when we're looking at numbers in word form to number form, how we count and read and write numbers. And then also it talks about using expanded notation. And that's more about bundling and tens and place value. And then the last skill it talks about is comparing numbers using greater than, less than, and equal to. Okay? So again, first thing I'm going to tell students and parents, when in doubt, make the frame. And if you think, oh, but I already know the frame, make the frame anyway. Really helps to break down and be able to translate these different forms. So the first thing they would do is make the place value frame that our number system is based on. And we know that those place values are always ones, tens, and hundreds. Ones, tens, and hundreds. And so when students are converting something from word form to number form, if the frame is there, it's easy for them to read and write the numbers and then transfer that knowledge into word form, except for the spelling, but we'll talk about that in a minute. So again, let's just say that in this frame, I put in our basic digits. These digits are no longer worth 123 or 1, 2, 3, 4, 5, 6. They're now worth 123,456 ones. And because those values have changed since we're describing them as a sequence of bundles, then how we read and write them also changes. So if I were to do this, I would take the largest period first, and I would write it 100, 20, because that is not worth 2, 3, and then as we discussed before, you then say the name of the period, then the comma, because the period is over, and then 400, 50, and 6. So that's how we would write it. The biggest problem students have usually is the spelling. And that's understandable because our numbers were taken from another language and added to the English language. Some from Greek and Latin, but some from other languages. So numbers don't tend to follow the rules of our standard phonics that other numbers do. So I help the students by breaking that down and decoding that for them. So the first thing we do is write down the basic numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then we talk about which numbers follow the spelling rules and which don't. So 1, if it were using our standard phonics rules, would probably be written like this. But in our number system, I help them to see that how should that really be? It should be own. And then the next number should be probably something like this or like this. But in our number system, again, it breaks the rules of phonics. So if it were following the rules, what would it be? It would be TWO. And then the next one does follow the rules, so we just write it that way. 3. The next one, 4, should be written as we write it in regular words, but in our number system, it breaks the rules, and it should be FOUR. 5 follows the rules of phonics. 6 follows the rules. 7 follows the rules. 8 makes them laugh because 8, if it were following the rules, would probably look like that. But in our number system, because we took this language from Gaelic, the word does not sound anything like it really is. It should be E-I-G-T. And then we have 9, which follows our rules of phonics, and 10, which follows the rules. And then we play the silly game of counting using the phonics rules, but saying it as if we were using the real rules that we use in English. So then the kids really enjoy saying, let's count. Own, two, 3, four, 5, 6, 7, E-I-G-T, 9, 10. So if you hear your children describing that at home, it's because it's a way to remember the proper spelling for these different numbers. So helping them to decode how to spell the numbers, they really do need to be spelling their numbers correctly by 4th grade. Really important skill. It's also very important that they apply their understanding of expanded notation in 4th grade, because we'll be doing some pretty complex multiplication problems later on. But to start them off, they need to be able to know that if I had a number like 932, how do I expand that to show what the place value is of each of these digits? It's in a certain place, so the value has changed. It's no longer a 9. What's that 9 worth? It's worth 900. The value of that 3 is not 3, it's worth 30. And the value of the 2 is 2. Now all I have to do is put plus signs in between these, and they are equal to the value of that digit. So we do lots of practice with that. The last skill they need to know is how to use the greater than, less than, and equal to symbol. That really focuses on making sure they don't confuse these two. And what we try to practice is when we read, we always start from left to right. And so you learned in lower grades probably that the alligator mouth likes to eat the larger digit, so you know if you eat from left to right, that one has to be greater than, because it's coming and eating everything to the left, and it wants to eat the larger things. So when you put the objects in a column, you put them vertically, and then you might compare different place values using these different digits and asking, well, which place is worth more? Since we now know from our previous exploration from the previous 2 or 3 weeks of review that digits to the left are 10 times greater, then we know this digit is worth 100, this digit is worth 10, this digit is worth 1. So now you can compare and order those digits. Okay, and that's number, sense, and base 2. Okay, so next skill we're going to be covering is number, sense, and base 10, 3. And this skill is rounding. Now, rounding tends to be really, really hard for students in September. Just conceptually, I feel like they need more time to practice place value before we start generalizing about place value and talking about which value is around which amount. So in my years of experience, I have found that sort of calming the situation down with a mnemonic story helps them not get stressed out. So I explained to them, I'm going to tell you a little story. It's just a little trick. And normally I really hate tricks in math, but in September I use this and it does tend to lower their anxiety. By the end of 4th grade, they absolutely need to understand rounding on a number line as well and in other ways, but I'll cover both so that you see the progression of how it changes over time. So usually I start by asking the students to give me a number that they choose. So let's say that the students chose the number 437. And we're trying to round this story. So I say, we're going to use this silly story to help you remember the rules. Once upon a time, there was a princess and she lived in a number kingdom. And in our number kingdom, they always will tell you where the princess lives in our rounding stories. So I let the students shout out, where does the princess live? And which place does the princess live? And she can live in the hundreds, the tens, or the ones. In this case, we'll start with the middle digit, tens. The princess lives there. And these people, because they are worth so much more, they are ahead of her. And so we pay attention to them, and they're still part of the number kingdom, but we're not going to pay too much attention to them right now. The princess wants to get married. She wants to be joined by one. But the evil man in the mirror, who always stands to the right of the princess, gets to decide whether the princess is married or not. If the evil man in the mirror gives her a high five or more, then the princess is joined by one. Is the princess going to get joined by one in this case? Yep. And the people above her get to attend the wedding. So let's bring them down here. And the princess is joined by one. And now the princess becomes a 4. Her name changed. And the man in the mirror, because he's magic, the man in the mirror becomes the mirror. Ooh. And the students will say, ooh. And anyone who was behind him also become zeros and say, ooh. So that's what the number becomes. And then we play with the story again and say, well, let's say the princess did not live in the tens place. What if the princess lived in the hundreds place? Then the evil man in the mirror would still be to her right. And in this case, is the princess joined by one? No. So the princess stays the same. And the man in the mirror did not give her a high five or more. So he becomes the mirror, and he takes all of those behind him with him, say, ooh. And that's how you teach it in September. The students really love the story. It's silly, it eases their stress, and it builds their confidence to understand rounding in an abstract way. But it's definitely not concrete, and I would never stop with this. This is just to get them to lower their anxiety around rounding. But then when we come back to it later in the year, after January, I remind them of the rounding story, but now I say, okay, so now that you've had lots of practice with numbers, yes, the princess story will get you there, but you don't really understand what you're doing. So now let's take that same story and we'll say, the princess lives in the 400s place. So then our number line, if we were drawing the number kingdom on a number line, our number line would begin at 400. And then what would the next number kingdom be? Well, the next one on the number line would be 500. And what would halfway there be to the next number kingdom? That would be 450. And now we use that same story and say, where does our number kingdom live? Where does the princess live? And so then they plot it, 1, 2, 3. That would be 430. And then, of course, 440. And so our number, 1, 2, 3, 4, 5, 6, 7, would be right here. Now, which number kingdom is our princess closer to? Well, she's around this one, not around that one. And because we use that story to lower their stress, they're more willing to play with it on a number line. Then we take this same system. If we changed where the princess lived to the tens place, and we say, now, where do the people ahead of her go? Well, they stay where they are, but they're not really involved. And the princess lives in the tens place. And where would be the next princess? That would, the people ahead of her stay where they are. The next place would be the next tens place. And then halfway there would be 435. And so would that change which number kingdom the princess belonged to? Absolutely. 36, 37. And there's where our number kingdom is. And it's closer to this one than that one. So you can see how it's kind of using the story just to lower the stress and have something silly in September, but still build their confidence so that they're ready to hear me when I start talking about number lines later. So the next video is NBT 4, and that is adding fluently. Most students don't tend to have a challenge with this one unless it deals with regrouping. And again, this is why when we talk about bundling in tens, bundling in tens, bundling in tens, it's so important for them to understand the 10 times more concept, and that's why they changed the skill from number sense to number sense in base 10. It really shows up in adding. So they're supposed to do it fluently, which means they should know their basic facts quickly. Having said that, they should also be able to talk about what they did. So let's say we have a typical problem at the 4th grade level, a 3 or a 4 digit problem. So then if I have 397 plus 184. The first thing I would probably do is connect their background knowledge from kindergarten, 1st grade, 2nd grade, 3rd grade to this problem. And I would draw it in pictures. So I would say, you know that the 100 flats look like great big giant squares, 300, and the 10s, 3, 4, 5, 6, 7, 8, 9, look like 10 sticks, and the 1s look like little dots. And then this number would be added to it, 100, 1, 2, 3, 4, 5, 6, 7, 8, and then dots again. Once they see it in pictures, then we talk about how we bundle every time we have a 10. So then start with concrete and then move to more abstract. So since we have 7 here and 4 here, can we make a bundle? And you always start with the smallest digits first. And yes, we can, so we're going to do that. We're going to lasso those together and make a bundle. And when we did that, what did we make? We made a 10 stick. So then draw a little arrow and show the 10 stick you made. Now let's make our numbers match our words, or our pictures. So now we made a 10 stick, and so we're going to add that to the tens column. And then we ask, how many single digits do we have left? How many ones? We only have 1. And that's why the carryover mark occurs, because we bundled. And then we move to the next place value, and we ask, do we have enough 10 sticks to make a bundle? And here we have 9, so if we add 1 more, yep, we can make another lassoed bundle. And what did we make? We made another 100 flat. And now let's make sure our numbers match our words. And now we ask, well, how many 10 sticks do we have left? 1, 2, 3, 4, 5, 6, 7. 7. And so again, now our numbers match our words. Oh, sorry, forgot one. 8. And I'm glad that happened, because in 4th grade, 4th graders often want to correct their teacher, and that's okay as long as it's building on their understanding and deepening their knowledge. So often in class, I will make a mistake like that to show the students that it's perfectly okay to make mistakes. It's just not okay to not check them and correct them. So that happens all the time, and it's not something I'm worried about. I hope it's not something you're worried about. So then we've done that one, and we've counted our 10s, and the last one we have to count is our hundreds. We have 1, 2, 3, 4, 5 hundreds. And before they walk away, you want to teach them the reverse operation of addition is subtraction. So before we walk away, we want to make sure to check our work using subtraction to make sure that any mistakes we made, we've corrected. Then we look back on this problem and we say, well, 1 minus 4 is not going to get me 7. So, how can I show that? Oh, that's right. We didn't just have one single, we had 11 singles. So 11 minus 4 equals 7. And having lots of conversations in class about this and being able to talk about it and being comfortable making mistakes is a large part of building fluency in addition. So 11 minus 4 is going to get me 7. And then we're going to use that same rule in our tens place. 18 minus 8 is going to get me the 10 here, because I have the 9 tens plus the 1 tens gives me 10 tens. And then we have 5 hundredths minus 100 gets me the 300 plus the 100, the 400 left over. So we're checking and we're talking about it and we're making sure we understand what we did. If your children come home and say, Miss Milani was wrong today, just know, I think all of our students need to be comfortable just being able to talk it through and show they understand. It's not about being right. It's about understanding your explanation, being able to provide good evidence for your explanation. So the next skill is number sense in base 10, 5, and that's subtracting fluently. There tends to be more fourth graders who have problems with subtraction than with addition. And that's because instead of bundling in those pictures, we're now breaking those pictures. So I do tend to have to spend quite a bit more time drawing the pictures of subtraction than addition. Addition usually takes 2 or 3 times showing the pictures and then they get it. They do still sometimes make mistakes, and again, the whole goal is to get them to talk it through, not just race, slowing them down. So let's say we have 427 minus 196. So now in subtraction, the first thing I have to show them is that you don't have both of these numbers. So if you're trying to prove your work and you're trying to show a picture of it, unlike addition, you're only going to draw a picture of the top number because that's really the one you have. So I have 4 hundredths, 2 tens, and 7 ones. So if I were to subtract 6 ones, can I do that? And yeah, I can do that pretty easily. Take 1, 2, 3, 4, 5, 6 away. And how many do I have left? 1. Do I have enough 10 sticks? No. So now I need to draw a picture of it again. And instead of lassoing them together to make a bundle, now I'm breaking the bundles. So I don't have enough tens to take away 9 tens. So I'm going to take one of these hundreds, lasso it, drag it over here, and make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 sticks. And now, just like we did with addition, I need to make sure that my numbers are matching my picture. So now I don't have 4 hundreds anymore. So I need to show that I took one of those hundreds and I broke it. And I now only have 3 hundreds left. And now I don't have 2 10 sticks. I have 12. And giving the kids the practice of drawing the pictures helps them understand conceptually what they're doing. So now I have 12 tens. Can I take 9 away? Yes, quite easily. So 1, 2, 3, 4, 5, 6, 7, 8, 9, taken away. How many do I have left? 3. And finally, take away one of the hundreds. Done. And how many do I have left? 2. And the last step is to check our subtraction using addition. 1 plus 6 is 7. 3 plus 9 is 12. 2 plus 1 is 3. And that's subtraction. So the next skill we're going to be working on is multiplication. And it's the primary focus of 4th grade. It's the key skill. And that's because when you and I were in school, parents, we taught multiplication using the standard algorithm that our parents used and their parents used. While I allow that method to be used once the students understand how we teach it in class, I don't encourage that method because when you ask students to explain their understanding of place value, when you ask them to break down the problem into smaller steps, it is much more challenging for them to explain what they're doing when they do it. So please bear with me while I show you the basic methods we teach in school. And these usually are the ones that parents get most frustrated by and often will say, oh, that new math, it's killing me. So the first one we do is partial product. And partial product is super important to get kids to connect everything we've been covering with place value to applying it to multiplication. And also giving them lots of practice with the vocabulary. Since the word product is listed in the description, it gives kids lots of practice with what the word product means. So anytime you do a multiplication problem, a factor multiplied by a factor equals a product. And when we do partial product, we take the problem and we break it into parts. So, first thing you do is give them a problem that's 3-digit by 2-digit. And they usually get a little nervous, but I tell them, don't be nervous. We're just going to go through the steps and we're going to apply everything we've done with place value to this problem. This method tends to be the one that parents don't like the most because they say, why do we need so many columns and rows? Why do we need to take up so much space? We need to take up so much space because it's really important for kids to learn to organize their work, learn to write their numbers in place value columns, learn to think about the value of each digit, and partial product really gives them that concrete practice in doing that, okay? So the first thing we do is we write the value above each digit and we connect what we did in number sense and base 2 to this. So that 3 is not a 3, it's worth 300. That 7 is not a 7, it's worth 70. The 2 is worth 2. That 1 is worth 10 and the 7 is worth 7. Now that we have the values above each digit, we can organize this massive problem to smaller problems below. We can break it into parts. The first thing they need to know is that these values on the bottom all need to be multiplied by the values on the top. So 10 is going to be multiplied by 300, by 70, and by 2. And then it's the other digit on the bottom's turn. So we're going to organize those problems below. So now we're not looking at the digit, we're looking at the values. So that 10 is going to get multiplied by 300 because that's really what you're doing when you multiply. And then that 10 is going to get multiplied by 70. And the 10 is going to get multiplied by 2. We now have the 10 multiplied by 300, by 70, and by 2. And again, the students are no longer looking at the digits, they're looking at the values. And then we do the other one, and we organize it below. So the 7 is going to get multiplied again by the 300, 7 by the 70, and 7 by the 2. So now we've broken this massive problem into 6 smaller problems below. So now we make 7 columns to organize our work. One column, 2, 3, 4, 5, 6, 7 columns. And now we talk a lot about the rule of 0 and what those zeros do in the digits. They're not just holding places, they're also representing 10 times more each time. Because we all know that 10 is worth 10 times more than just 1. And 300 is worth 100 times more than just 3. Well, the rule of 0 in multiplication says those zeros do the same job in the product as they did in the factors. So we can move them and they'll do the same job. So how many zeros do we have? 3. And so we don't have any ones, any tens, or any thousands. And now we just do the multiplication. 3 times 1 is 3. But it's not 3, it's 3,000. And that's the rule of 0. I'm abbreviating it here, but we talk about this in class a tremendous amount. Once you've done that problem, again, stay organized, underline it to show you're done with it. The next one has 2 zeros, so we move them. We have no ones, no tens. We also have 100 times more, whatever the product of this is. So 7 times 1 is 700. But it's 770 times 10, 100 times more. Okay. Underline that one. There's 1 zero here. 2 times 1 would be 2, except the rule of 0, it makes it 10 times more, so it's 20. 2 zeros, 7 times 3 is 21, but it's not 21, it's 2100, otherwise known as 2100. And 1 zero, 7 times 7, 49, but not 49, 49 tens or 490. And then 7 times 2 is 14. And then we add up all our parts. So because we've just done addition, this is pretty easy for them to do. The toughest part is getting them to sequence their steps. So saying 0 plus 0, 0 plus 0, 0 plus 0, 0 plus 0, 0 plus 4, 4. 0 plus 0, 0, 0 plus 2, 2, 2 plus 0, still 2, 2 plus 9, 11, 11 plus 1, 12. 0 plus 7, 7, 7 plus 1, 8, 8 plus 4, 12. 1 plus 3, 4, 4 plus 2, 6. And getting them to hold those digits in their head is really important. So having them go through sequentially helps. Okay. The next method I'm going to show you is multiplication wrestling. It's a preemptor to quadratic equations that they'll experience in high school. Very similar to partial product, but different in that the students are probably using parentheses as an operation for the first time. So now we're going to take a look at this same problem, and we're going to remember what we did with partial product, and we're going to extend that understanding. So let's take this same problem, and I'll show how we organized it using partial product. And then I'll say, do you see how this number is written in expanded notation? The only difference is there aren't addition symbols between the different values. So this is the same thing as 372. So let's put this in parentheses and call that an expression of 372. So they're learning a lot of vocabulary when they're going through this. What operation are we doing? Multiplication. And now let's write 17 as an expression written in expanded notation. And put that expression in parentheses as well. And now this is the same problem, it's just organized a very different way than what they're used to. And so once we organize this problem this way, we talk about why this method is called multiplication wrestling. And a lot of that is just to lower their anxiety and stress. It's to show them that don't get scared. It's just a different way of organizing their thinking and their understandings. So in wrestling tournaments, each player from one team wrestles all the players on the other team. And in this way, we're doing the same thing. So we're going to record the wrestling matches with arcs. So 10 is going to wrestle 300. And 10 also needs to wrestle 70. And 10 also needs to wrestle 2. Is 10 done wrestling? Yeah. Now the other player gets to wrestle. And we're going to record those matches. 300. And then at this point, the students tend to say, oh, this looks like partial product. Yeah, that's why partial product is where we start. It's foundational to all the other methods. And then we're going to organize it in columns because we talk about rows and columns, rows and columns, rows and columns so much to help them, again, connect vocabulary to other areas. And then we use the same rule of 0 and we compare the result we got from multiplication wrestling to the result we got from partial product to give kids practice with both. So then the next method we use is lattice. Lattice is what Texas uses primarily as their top one. It's my least favorite method, but the kids really seem to enjoy it, especially on very, very long problems. So lattice has a lot of procedures in it. So let's say we have a 3-digit number, 934 times 86. With lattice, you organize the problem, one of them vertically and the other horizontally. So let's say we're going to put the 934 across the top of the box. Then down the side, we would put the other digits, 86. With lattice, each number gets its own box. So let's give each of the top digits a box. 9 gets a box, 3 gets a box, 4 gets a box. Now let's give the other digits a box. 8 gets a box and 6 gets a box. We're almost done. Now we need to cut the boxes in half. And from this point on, all work we're going to do will start from the inside out. So we're going to cut the boxes going corner to corner. Corner, out. Corner to corner, out. Corner to corner to corner, out. Corner to corner to corner, out. Corner to corner, out. Corner, out. Now each box has been cut in half. Now the fun part, the kids just practice their multiplication facts. Where the 2 digits meet, that's where the fact goes. The 10s go in the top half of the box and the 1s go in the bottom. So 8 times 4 is 32, 3 10s, 2 singles. 4 times 6 is 24. 8 times 3 is 24. 3 times 6 is 18. 9 times 8 is 72. 9 times 6 is 54. And now all our boxes are full. Now the only challenge with lattice is when you go to add. When you add, you have to do it diagonally. So whatever the sum is in this column is what that column gets. So this column has 4. And I asked the kids, just as a further scaffold for this method, when you add up and there's a carryover mark, I would recommend you circle the carryover mark because it's easy to miss them. So this one has 4. Now we're on to this column. 2 plus 2 is 4, plus 8 is 12. So carryover mark gets circled in the next column, and the 2 stays here. It's harder to miss when it's circled, so now we're in this column. 1 plus 3 is 4, 4 plus 4 is 8, 8 plus 1 is 9, 9 plus 4 is 13. And now we're in this column. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 5 is 10. 1 plus 7 is 8. And then we connect it with our place value frame by putting a comma after the first 3 digits, and it's 80,324. Once they've learned this method, they then learn the area model, which is this method applied in an area picture. I do want to warn you, when using the area model, each digit is written in expanded form. So 900 gets a box, 30 gets a box, 4 gets a box. It's similar, as you can see. And then we use the rule of 0 . 9 times 6 is 54. 2 zeros, 24, 18, 1 0, 32, and 24. And then we would add up all of these parts to get that. I'm not as a fan of this method because I think it makes it confusing later when we do area to say that this is how much area this particular value would take up. Is technically wrong because that area is much, much larger than that area. But they do it so that kids can, again, be practicing the value of the digits, not just the digits, and also breaking the large problem into smaller problems and talking and talking and talking about it. So the last skill that I'll be showing you is number sense in base 10-6. We'll be moving on from number sense in base 10 to operations and algebraic thinking later. But for now, to end number sense in base 10, which would probably bring students to about mid-October, we cover the basics of division. So the first challenge with division is that students tend to have an easy time understanding that 3 times 4, another way to say that is 3 4 times, or another way to say that is 4 3 times. And they get that multiplication is a form of repeated addition. But what they don't understand is that division is just a form of repeatedly subtracting. They don't understand that intuitively. So the first method we teach helps them to understand that all division is repeated subtraction. And so we start to lower their anxiety by using the mnemonic, Dracula's mother sucks chicken blood. And you can use any words you want, but you want to choose something memorable so that the kids remember the steps. So the first step is Dracula, which is the divisor. The next step tells you need to multiply. The next step tells you subtract, followed by check it. and bring it down. So if we took a simple problem like this, again, you want to reinforce to kids, math is similar to language arts. We read from left to right. And in this problem, the question, I can't work with it when it's written like this. I have to use the other way we show multiplication, which is that symbol. So often students will get confused which number goes inside and which number goes outside. If you know you read from left to right, the first number you come across is the first number you write down, 12. Then divided by, and now there's no place left to put the 3 but on the outside. With this method, they're going to put a line down this side. So I tell kids, with this method, even if you don't know your multiplication facts, you can still do complex division problems. For this very simple problem, I could suck out 3's one at a time using the steps. So I'm going to show you what that looks like. So that's my Dracula, that's the divisor. I'm going to ask myself how many of these I can suck out. Well, I know I can suck out 1. So I'm going to put the 1 here. That's how many divisors I'm going to suck out. So my next step is multiply. 1 times 3 is 3. My next step is subtract. Put a line here to say this is the problem I'm working on. 12 minus 3, I'm going to break my 10 stick. I'm going to give it to the ones place. Now I have 12 ones minus 3 ones is 9 ones. Check it. We know the opposite operation of subtraction is addition. 9 plus 3 is 12. Bring it down. This is still larger than this, so I can keep going and go back to my first step. Then I'm going to take out another one. 1 times 3, I'm on multiply. Now I'm on subtract. Now I'm on check it. Brought it down. I can take out another one. 1 times 3 is multiply. 6 minus 3 is 3. Now I'm on check it. Bring it down. One more. 0 left over. My last step is to list my remainder. I can either write my remainder as remainder 0, or I could write my remainder as a fraction, 0 out of 3. Now my last step, count my Draculas. We're back to Sesame Street. 1, 1, 2, 3, 4 3's in my number. This is a really simple one, and that's usually what I do to introduce the procedure. Then we quite quickly go to our rule of 0 and take the same problem, but add zeros. That's not so freaky for our students because they're used to playing with base 10. They're used to playing with zeros. They're used to talking about what those zeros represent. So now they know 120 divided by 30. How many 30s can I suck out of 120? Well, I have 2 digits here, and if I put the 3 in the tens place, I know I'm going to have to borrow 100. So I know I could suck at least 1 out. 1 times 30 is 30. Subtract. Borrow. Break that 100 stick. Give it to the tens place. 12 tens minus 3 tens is 9 tens. Now I'm on check it. I brought it down. I know I can suck another one out. So you can see how it's expanding on that rule. So now I'm going to move to a quicker, more complex problem. If I had 127 divided by 8, most students don't know their multiplication facts, but they do know the rule of 0 enough to say, if in my factors, I put a 0 in the ones place, then this would become 80, and the 8 would go here, and I know I can suck that many out. So we start by sucking out 2s, 5s, 10s, or 100s, the easy multiples, because it's really all about getting them used to the procedure. So now we've decided we're going to suck out 10 8s. Now we multiply. 8 times 10 is 80. Now we subtract. I'm going to break that 100, give it to the tens place. 12 tens minus 4 tens, or minus 8 tens is 4 tens. Now we check it. 7 plus 0 is 7. 4 plus 8 is 12. We brought it down. I know the basics of my multiplication facts. 8 times 5 is 40. So now I'm on multiply. Now I subtract. Now I check it. And I brought it down. This is less than this. So again, I can write the remainder. Either remainder 7, or I could write remainder 7 out of 8. And now I count my Draculas. 10, 15, 15 8s in my number. So the last method is what we use just before they go into 5th grade. It's what Taiwan uses. Taiwan connects division to place value extensively. They see it as an opportunity to solidify understanding of place value. So since we've been talking about place value all year long, just remember this method they'll be learning at the very end of 4th grade. So now we're dealing with digits that are multi-digit. So let's say we have 123, actually 1,234. And we're going to divide it by 5. Using the place value method, we have each digit get their own place value column. And we also extend this into decimal values, because by this point we've talked about how decimals are whole numbers broken up 10 times more each time. So this would be wholes broken 10 times, and this would be wholes broken 100 times. So what I tell the students is, let's look at how many place value columns we have. And to lower your anxiety, let's cover the digits up and just look at the place values. So I have a ones place, a tens place, a hundreds place, and a thousands place. Okay? So I know I have 1,000. So now I have to use my knowledge of my multiplication facts to practice. So I'm going to reveal just the thousands. So now I have 1,000. My question is, do I have any 5,000s that I could suck out of 1,000? Clearly not. I don't have enough. So in that column, I'm going to put a 0. Now I'm going to reveal the next place value. That's the hundreds place. I could either say I have 200, or I could say I have 1,200. And that's really what I have. I have 1,200. So now I ask, how many 500s can I suck out of 1,200? That would be 2. 2 times 5 is 10 hundreds. And then we're connecting our rule of 0 again. Now I'm going to subtract that. I have no thousands left. I have 200, I have 30, and I have 4. Once I've brought it down, I cover the whole thing again. I reveal this place. I know my facts are correct because this column is taken and this is less than that. I know this is correct because this column is taken and this is less than that. So I know I subtracted out the most that I could in that place. Now I'm in the tens place. I have 23 tens. I have to know my facts, so how many 5 tens can I take out of 23 tens? That would be 4. 4 times 5 is 20 tens, otherwise known as 200. Now I subtract. Now I cover it again. I have no hundreds, but I knew that because this column is taken and this is less than that. I'm in the tens place. This column is taken and this is less than that. I'm in the ones place. I have 34 ones. I can suck out 6 fives, which would give me 30 ones. I have 4 left over. If this were Dracula's mother, I would stop here. I would say I have 246 fives in my number with 4/5 left over. But the place value method helps kids extend their understanding into decimal territory. So I say I have 4 singles left over. What if I dragged those 4 singles past what I call the destroyer landline, and I take those 4 singles and I chop them up? How many would I chop them into? Well, when we're dealing with decimals, it's always tens, because decimal system is based on our number system of base 10. So if I took those 4 singles and I chopped them up 10 times, then I would have 40 pieces. So now I use that same method again, cover it. I'm in the ones place. I can't take any more out because this column is taken and this is less than that. I'm in the tenths place. How many 5/10ths can I suck out of 40 tenths? That would be 8. 8 times 5 is 40. And I've sucked out as many as I can. So now I'm deeper understanding place value, and I'm also extending my understanding of division into decimals.